Hello friends, I welcome you all to this lecture on Python programming. Today what we'll be doing is we will be learning that how to check whether a number given by user is magic number or not. What is a magic number? A number is a magic number if repeatedly summing its digits until a single digit gives 1. What does that mean? So let's say 19. So if I add the digits, what I'll be getting? 10. Again, is this a single digit number? No. Then what I'll do? I'll add the digits again. So is this a single digit number? Yes. And that is equal to 1, and hence that is magic number. Similarly, what you can do is you look this number 28. If you add these numbers, what will you be getting? 10. And if you add them further, what you will be getting? 1. So in this way 28 is also a magic number. So let us write a program for it and see whether this happens or not. Now to write this program, what I'll be doing is I'll be simplifying my task of writing a program and making the program more elegant. How that can I do? That can be done with the help of using functions. So if I start building up functions, then it becomes very easy for me. Now the question is, how many functions do I require? 2. The first function is to add all the numbers present in a digit, and the second function should be to tell how many digits are there in a particular number. So let us make the first function, that means how many digits, or let's say how many digits. So for that I'll be requiring math module. Now friends, there is another way of writing a function, that is what we call as lambda function. Now this you have already seen def, but what is lambda function? If I have to write a function which contains only one line, for example, y x is equal to x square plus 2. Let's say this is my function. Here this is a single statement which I have to put inside that function. How I can do that? So I have to write like this. Look very closely. First the name of the function will be y, then assign lambda, lambda, that is what we call as lambda function. Then how many arguments this lambda function is using right now? So you look here, it is only taking one argument, that is x. And then the body of the function, the statement, what it should return? This one. So it should return x square plus 2. And that's it. We have developed this function, single line function. So if I want to know that what is the value of y when x is 1, so you know when I place 1 here, so it becomes 1 square, that is 1 plus 2 becomes 3. So it should return 3 to me. Why it is not returning 3? There is some mistake. What is the mistake? I have not supplied the argument. Remember, after lambda you have to supply the argument. So it is x. So if now you run it, it will return you 3. So what is the procedure, or what is the syntax for it? The name of the function, then assign, then lambda, and then the argument of that particular function, then colon, and then the statement. That's it. So here what I'll be doing is I'll be writing a function for finding out the number of digits. So let's say number of digits is equal to then lambda, then what that will be requiring? A number. Yes, a. Then you all know how to use it. We have used this log 10. If we supply it, that function, and then typecast it to integer and then add 1 to it, I'll be getting the number of digits. So let me make it big. Okay. So now if I check this number of digits, and let's say how many digits are there in 100? How many? 3. So the function should return 3. Oh, C is also already there. So it is. So let's say how many are there now? 4. So it is 4. So let's make a bigger one. How many digits are there? 6. 2, 4, 6. In this way this function works. And now you know that how to write lambda function. That is one liner function. Now comes another function. Let's say we will be making what? Summing up the digits. So we can't use this lambda function because that particular function requires more than one line. So digit, so let's say digit sum is that function name, and that will be requiring some argument, the number itself. So sum assigned 0, Then while the number is not equal to 0, then what we have to do, we have to find out the remainder and then add it to s, and then we have to reduce one last digit from the number. So I can write r is a, then modulo 10, then s assigned s plus r, okay, and then I have to reduce that a by using floor division. And then finally you have to return something. What is required? Sum is required, so I have to return this s. So how this works? So if I write and then I say sum up the digits in this number, how many ones one are there? 1 1 1 1, 4 ones are there, so the answer should be 4. So if I run it, I am getting 4. So let's say I want to know what is the sum of this. So it is 3 plus 1 4 plus 2 6 plus 1 7. So answer should be 7. So that is how this works. Now comes our main program. So it says we have to do what? We have to take one number, okay, and then we have to add the digits of that number till that particular number gives me what? Single number. Okay, so how that has to be done? So what I require is the number first, enter a number. I'm asking this to the user that please enter one number. Okay, then what? Then I have to check while the number is not having single digits, till I have to do this, because you have seen here it is 19. When I have added all the digits, I am getting 10. Is it a single digit number? No, I have to do this till I am getting a single digit number. So what I have to do, I have to say what is the name of the function? Number of digits. Okay, till the number of digit for this number is not equal to 1. Repeat, do what? Sum up. So I am having a function called as digit sum. So sum the digits of this n, and assign it to n itself, so that we can compare same number again and again. And in this way, so let's print this n for your convenience. Okay, so if I run, so let's say I am giving 1 1 1, okay, or bigger number, let's say 1 1 9, let's say. So 9 plus 1 is 10, plus 1 11. So at the first instant it should give me 11. Then again, is it a single digit number? No. So the again loop will run. So that 11 will be added. So 1 plus 1 becomes 2. So that will give me 2. Now it is single digit. It will come out of the loop. So let us run. Let us run it. So that is what is the answer. 11 first and then 2. So now it is very simple. So if the number, that is the one which you are getting after final reduction, is equal to 1, then simply print that the number is what? It is what? It is magic number. It is magic number, else it is not magic number. That's it. Else the number is not a magic number. So if I run it, what was our original example? 19. So let us give this 19. So the number is a magic number. Okay, so because it is giving me 1. So let us take another example. Let's say, what should I take? 1 2 5 6 7 8, then 2. So 1 2 5 1 2. So is this a magic number? Let us check. Oh, sorry. So at the first instant it will become 11, and then this will be 2. So the number is not a magic number. So here you can check 5 plus 2 7, and this is 8, and 9 10 11. So it is not a magic number. So let's take 28. Whether 28 is a magic number or not? Yes, then it is magic number because it is returning 1. So friends, now you can see that by using functions, how can you reduce the size of your main program as well as how elegant the program can become. So friends, in this lecture, till this point only, in the next lecture, we will be solving some more problems. Thank you very much for your patience.